if you can uh, yeah, if you can recollect coincidental and line clipping, these are all we did. So we don't want now. We have the second program. Mm, Second program is here. Okay, why am I teaching second program, or how can I afford to teach second program? Is second program's theory has been done already in the class. That is translation, rotation, scaling. 2D. That is module 2 we have done, and that's the reason I'm doing it now. So time is 11:25. We shall quickly add it. We shall quickly do this. Let me keep the meet window so that if you have any doubts, you can write here. All right. So second program is all about create and rotate. First is you need to create a triangle, and next is you need to rotate this triangle about 2 pixels, about two guys, about the origin and a fixed point. So let me show the output. Yeah, when I enter fixed point for rotation, let me say I'll give 200, 200. So I'll get a window like this, a black window with this red polygon, red triangle. This white window, this white pixel happens to be 0, 0, and the right click, rotate around the origin means at 0, 0. Next one is rotate around fixed point means what is my fixed point? It is 200, 200. So from 0, 0 to 200, 200 is this blue color pixel. So with respect to that pixel, it should rotate. So again, if I right click, if I say origin means it comes here. If I say fixed point means it goes to 200, 200. That is my customer point, and then it rotates. Third one is stop rotation. Now this is called as a menu. This comes in your fifth module. I will teach now itself how what is menu and how do you attach the items in the menu and how do you play around with this mouse. Now that we have understood the the output, that is the black screen, white pixel here, a blue pixel here, and a red polygon and rotation, we shall see how exactly we can do this. Right. So come from the, let us consider the globals. XY is your customer points. Where to rotate is equal to 0 means initially don't rotate. I will teach you in a bit. Where to rotate, if it is 1 means rotate around the origin, if it is 2 means customer coordinate, 3 means stop. So other than 1, 2, 3, you can take 0, you can take whatever number you want. So other than 1, 2, 3, if you write anything, for example, let me write here as 1. So what is 1 according to us? If that where to rotate is equal to 1 means I should rotate around the origin. By default, I'm saying, by default. For example, so I'll run the output, I'll run the program, I get, let us say 100, 100. You can see by default, it will rotate around the origin. Now, by default, if you want your polygon to rotate around the fixed point, that is, fixed point means where to rotate is 2. So by default, if you write 2 here, that means you, without your menu interaction, it will keep rotating at your fixed point. You can see here. So by default, where exactly to rotate. That is the reason the variable name is where to rotate. Now, So where to rotate variable will just tell you where to rotate. That is either at the origin or at your fixed point. What? Now if you write 3 here, what is 3? 3 is stop rotation. So by default, stop it. That means by default, don't rotate. You might as well say that. So if you say 100, 100, so by default, it doesn't rotate. So now you can say origin or this or this or what. So other than 1, 2, 1, 2, in fact, you can give 3, no problem. You can give any number. Uh, so it doesn't matter, because one other than that number, since it doesn't know, it doesn't matter. So it all depends on you. Would you want to do you want to keep rotating about the origin or fixed point by default? You can choose that. So this is the story about where to rotate. Rotate angle. Initially it is 0. Translation factor of x initially 0. Translation factor of y initially 0. What do you mean by translation factor? Right. Now let me say 100, 100. So please look here. From 0, 0, how exactly I go to this 100, 100. So in module 2, we have seen what do you mean by translation? It is moving. So from 0, 0, I have to move towards 100, 100. That is your translation factor. Since this is a 2D rectangle, 2D triangle, translation factor of course means it is I have to go some distance by x, some distance by y. Then only I get 100, 100. So in a nutshell, translation factor of if you are 0, 0 and if the translation factor is 100, 100. So x translation is 100 and y translation is 100. So initially translation factors are 0. So as and when I get it, as and when I get the customer coordinate, I'll make sure I'll go there. So initially rotation angle 0, I'll slowly increment. Now there are global functions. Uh, there are functions one, two, there are two customer functions. One is your display, of course, that is your display func out display, and there is one more to initialize, and there is one more for your main. So I'll come from the main function. And since I'm done with the global variables, so let me not teach you this function now itself. As and when we call this, we will explore that function. All right. So start with main. Ask the customer points 100, 100, 200, 200, whatever. Take it in x and y. Glut in it, initialize the graphic system. So double, single also works because don't consider this as animation. This is not animation. This is just rotating by point, rotating by how much degrees, rotating by 1 degree. It looks like an animation, but it is not. So you might as well take single as well. And my coloring scheme is RGB. Yeah, and yeah, this is important. My window size is 800 by 800. My initial window position is 0, and this is my triangle. Let me start with init. Now go to init. Yeah. So clear color, all these are 0, 0, 0. Why? Because this is my black screen. So I should apply black. Matrix mode of projection. What is projection? By default, orthographic projection applies. Load identity, this projection and load identity I have not taught you, so I'll teach you now. Understand carefully. Projection, load identity, and this model view. I'll explain you in simple terms. Please look here. Fixate point, let me say. Now it is rotating, let me say not as 1 degree, let me take it as 0.01 or 0.01 degree. Now, let me say fixed point. What do you mean by load identity, projection, and model view is something like this. You can understand with this example. Now there is this polygon is rotating for every 0.01 degree. Now let me say my initial triangle, initial polygon is something like this. And how do I show this to my customer? I should click my camera. So that is what this is what this data. This is GL projection. GL projection by default it projects orthographic, and by default even if you don't write this, because it always rotates. And why we didn't write this in my earlier program is we didn't do any animation, we didn't rotate, we didn't translate. So it was a static image, we only showed a static image. Now since this guy involves some motion, so instead of writing that image every time, what I'll do is first I'll project it. Project it means whatever is your output, project it. Next, because every time, every second, every millisecond or whatever, every time, since it rotates, that rotated triangle, instead of redrawing it, let me calculate from wherever it was and now wherever it is. That displacement is what this guy does, load identity. Load identity means it will multiply that particular displacement with the identity matrix to get the new coordinates. And this GL matrix mode of model view, what this guy does is it shows the changed image. It will now apply this multiplication matrix, model view matrix. There are some transformations in projections. Once I teach you in module 4, I'll talk about this orthographic parallel projection, perspective projection later. For a time being, you should understand something like this. GL projection means whatever is the output, the current state, you show it. Load identity means anyway it changes its identity. The mathematical concept is it multiplies with the identity matrix with the new coordinates and with the old coordinates to get the new coordinates. But for the time being, understand something like this. Real projection means project the current image. Load identity means since it changes, load the identity matrix and get the new one. Model view means it multiplies and it gets the new image. And again, it happens. Real projection means it shows the new coordinates, new position. Load identity again, it would have changed by 0.01 degree. Model view 0.01 degree image. You need to show that. What I'll do is comment this now so that you will clearly understand the effect of this. So comment this out and show this. It has 100,100. You can see here the image itself has been changed. Rotation around the origin, fixate point. Fixate point means it is not at all to be seen. If I say origin means it comes here. If I say fixate point means it doesn't know where to go and it stops. This is stop. This is good. So every time you are changing it, you are not able to closely associate your polygon. So that's the reason you should write these. I will teach you more about these two and this in my class, because I should have one real-time entity. We will rotate it, we will translate it, we will scale it perhaps, and then the scaled image, the new image, every time it loads, how exactly to load it. So these three lines. All right. So now comes this line, why this is minus 800 minus 800. Now it involves some small mathematics. Look here, my display func of display, before that my window size is 800 comma 800. That is, this is 0, this is 800, this is 800. Now how exactly I get this as 0 and I want within 800 by 800 window, I want this to be 800, this to be minus 800, this to be plus 800, and this to be. So that is what I'm doing now. 800 by 800 size. So what I'll do is I'll split it. So left is minus 800. This is LRBT, right? If you remember, this is L comma R comma B comma T. So left is minus 800, right is plus 800. So if left is minus 1 and right is plus 1, the middle is obviously 0. Right? So minus 800 plus 800. This is my left is minus 800, right is minus 800. Bottom is minus 800, top is plus 800. So hence this is 0, 0. You can ask me why. This is purely my wish. You can take any size and any camera coordinates, no viewing coordinates. It's just that I can show to my students that the triangle is situated at the center. This is my mathematics adjustments. If you don't like this, you can easily change all this and take your own viewing coordinates. So that's it about your init. Now let us come to display func of display. Now display func of display is here. Here color buffer bit. So whatever you have set here 000 to display it, apply it. Load identity means the original position you load it. Color 3FF RGB, that is red, green, blue. Take equal proportions. You will get white color. White color means this one, this pixel. I have not drawn it only. So draw pixel 0, 0. Now please tell me if this is 800, 800 and my viewing coordinates is something like this. Obviously 0, 0 means this. I am sending 0, 0 as parameters to my draw pixel function. So draw pixel function, take this as 0, 0 now. My parameters are 0, 0. Point size of 5, a thick one. A thick pixel, you can say. X begin points, vertex 2, floating point, or double or I also works. X1, Y1. So X1, Y1 is 0, 0. Plot it, end it. Plot a single point. So plot the single point. This is done. Next. If where to rotate, now comes this. Where to rotate is 0 now. Now I'm saying, is that guy 0? No. Is that guy 2? No. Coming. Translate X, translate Y. Translate X is 0, translate Y is also 0. Means, see, understand, translate is a OpenGL translation function. Belongs to GL property. F is the data type of the parameters. Translate function takes 3 parameters: X, Y, Z axis. So since this is a 2E guy, so all my Z axis is 0. So translate X and translate Y. In which case my where to rotate is 0. I am saying, is that 1? No. Is that 2? No. Come here. Translate X and translate Y. So both the guys, translate X is 0, translate Y is 0, and this is anywhere 0. That means I am not performing any translation. So wherever I was, I am staying there. In which case, if my where to rotate is 0. Come. Next, rotate it. Rotation angle is what by default? 0. Mind you, whenever you go inside, you are changing the rotation angle. Since I have not gone inside, my rotation angle remains 0. So rotate function takes 4 parameters. F is the floating point. First is what angle I need to rotate. Second is x axis, y axis, and z axis. Since rotate angle is 0, I will not rotate at all. I am now teaching you this stop rotation step. Translate x minus translate minus. This I will teach you in some 2 minutes. Why this is minus angles, and that is why are you writing one more translate. This I will come back to this in 2 to 5 minutes. Next is what you need to rotate. You need to rotate exactly the triangle. So call this triangle function by passing the translation factors, because if you go to fixed point, you are actually translating the triangle, right? In the triangle function, I will write a triangle. That's a different issue. But why are you passing translation factors as into my triangle? Is you are actually pushing the entire triangle, the translated one, to the fixed point. That is why you are passing this. Translate x and translate y, both the guys are 0, 0. You will now pass to triangle. Now, in triangle function, now both the guys are 0, 0 now. Both the guys are 0, 0. Color 3F, this is, what is this? RGB, that is red color pixel. Triangle is nothing but a polygon. You might as well write GL underscore triangle as well. Since I wanted a fixed, or I mean a filled one, I thought I'll write polygon. Vertex 2F of x comma y. Now comes the interesting stuff. X comma y is this. Let us say you have given 100 comma 100. So this is your x comma y. So now in triangle, fixed point, these are being stored in x comma y, and since you are passing triangle, translate x and translate y, so those will be overwritten. These are anyway my formal parameters. This will now hold 0 comma 0. Now vertex 2f, first point 0 comma 0. Next 0 plus 400, 0 plus 300. It is anyway 400 comma 300. Next one 0 plus 300. It is 300 plus 0. Can you now tell me what are these? I'll repeat. X and Y, don't confuse between this section Y, and this one. So this X and Y is your global guys, that is your 100 comma 100. But since you are in blood display form of display, you are calling this triangle by passing these two parameters. Right now it is 0 comma 0. So the same 0 comma 0 will be copied to x and y. So now these are my points. Tell me what is this? 0 comma 0 means this point. 400 comma 300, something this point. 300 comma 0. So you may not understand this. One second. I would like to show what is 400 comma 300 over here. This is your global guys. Yeah, this is what I want. 0, 0 is here. 400, 300, this point. 300, 0 is this point. First point, second point, third. This to show this. So triangle is over. Glut post redisplay. Call this display function again and again because this guy keeps changing every second, every millisecond. So instead of main calling display func of display again and again, so you write this function glut post redisplay. It will keep on calling this display again and again. Glut swap buffers. This I have taught in the class because this uses glut double, glut underscore double. And I have not written GL flush. So since I use double buffers, you please keep swapping the buffers, which I have taught you in my class. All right. Now I have taught you this guy. Stop, that is where to rotate is 0. Now what I'll do is I will make this, select this guy, rotate around origin. So in that case, glut display func of display. This is, understand guys, this is something really important. This is my menu operations. Come here, create menu, rotate menu. Glut display func of display. What is the argument? The function name. Glut create menu is again a callback function. The argument is the function name. Function name is rotate menu. Rotate menu has by default one parameter called one integer parameter. If that integer parameter is 1, means to say if you select the first guy, if the option is equal to 1, where to rotate guy as 1 from the default guy as 0. From the default 0, whenever the customer chooses the first option as 1, you write your logic where to rotate is equal to 1. Whenever my customer chooses second option, make sure your where to rotate is 2. Whenever my customer chooses the third option, make sure it is 3. Now, since I have chosen rotate around origin the first option, now since this is post redisplay, this display function gets called again and again and again. Now again comes here load identity, whatever, red pixel, draw pixel, fine. Now what is my where to rotate? It has got changed to 1 now in this function. Where to rotate is 1. That means whenever you select in the right click menu and select the first option means you are changing where to rotate is equal to 1. Now where to rotate, if this guy is 1, is 1 equal to 1? Yes, go inside. Now you can see here rotate around the origin means I should not translate. Rotate around the fixed point means I should translate. In the origin means I should not translate. So translate x, make it a 0. Translate y, make it a 0. No translations for rotation around the origin. And since you should rotate, so rotation angle is equal to rotation angle plus your degrees, 0.01 or 1 degree, 2 degree, whatever. All right. Now since rotation angle is changed and translation x, y are also changed, it will now come here. Where to rotate is 1 is equal to 1. Yeah, it goes here. 1 is equal to 2. It doesn't go here. Again, it comes here. Translation function it calls by passing these two. Translate x is 0, translate y is 0, and the z parameter is 0. Rotate it with 0.01 degree and translate it, negate it. Now what I'll do is I'll comment this, then you will understand the implication of that. So run it, you will get, let us say 100 rotation around the origin. You can now see that this negative translation is not at all making any difference. See the output, still I'm getting it. Even though I have commented this, I'm still getting this. Now comes the real magic. I will negate this. Anyway, I have commented this. I will run it. Origin means no magic. Fixed point means you can see here the fixed point is 100 comma 100. From this it has gone to again a 100 comma 100 distance. See what I'm doing is translation. Now translation factors are what? Because you have chosen the second option. The moment you choose the second option, your way to rotate is equal to 2. All right. If where to rotate is equal to 2, that means where to rotate is equal to 2 now. 2 is equal to 1. No, it doesn't go here. Where to rotate is 2 now. Is 2 is equal to 2? Yes. Now comes this. Translate underscore x is equal to x. X is your customer point. So translation factor, what have you chosen? 100 comma 100. Now translation factor is now 100. X is equal to 100. This is also 100. Now translation factor is 100. Translation factor of x is 100. Translation factor of y is 100. Now what are you doing? You're saying, boss, you translate 100 comma 100. That means wherever you have plotted, from this point you go to 100 comma 100. That is why it is seeing it is rotating at this circumference. At this circumference. Getting it? I am rotating it. Translating means going from wherever you are, from 0 0, from wherever you are, you go to 0, 100 comma 100 and rotate it. But the point is you are not coming back. So this coming back concept is this negative translation. What I'll do is I'll now comment this. You will now understand. So 100 comma 100. Again, mind you, for origin it doesn't matter. For fixed point, you can see here, fixed point also it is revolving at the origin. Now what has happened? It would have gone there. No. Since you have commented it, it has not gone there. Rotation function, fine, it is rotating, and translate negative back. Negative. That means you're coming back. That means you should go here, rotate, and stay there itself. So that is not happening here. You are not at all going, and you are pulling yourself back. That is why your fixed point is appearing to be at the origin. Now comes taking out these, executed 100 100. Now comes the story. Origin means no problem. Fixed point. Now comes the point. Now plus translation means it has gone here, from here to here at this point. Rotation finds. Negative translation means from wherever here to again to this point. That is how I can simulate that it is rotating at the origin. So if you don't do this negative translation from here to 100, so it goes with this point. Here. If the triangle rotates here. And if you don't do positive, if you do only negative, the rotation will happen with the origin itself, because you are going back, and you're not at all going and you're coming back. So if you do both, it goes here and it again comes back to 100 comma 100, so that it appears that it is translating that. So what you do is, if you're not understanding this, comment it. Comment the first one, run it like I did. Comment the second one, run it, and then uncomment both. You'll understand the difference. Right? Fine. Now, so whenever you right click and choose 2, you will see rotation angle is equal to 2. Translate it, rotate it, and what is this? Color 3F of 001. That is your blue color. This blue color. That is this 001, and draw pixel. And I want to show this pixel. So I have written. So any doubt? So display func of display is over. Keep on swapping the buffer. So rotation menu is over, and the other entries. Yeah. How do you attach the menu? Add menu entry is what you should take, and these are all, mind you, these are glut properties. Glut create menu, glut add menu entry. So what do you want? Rotate around the origin. Second one, rotate around the fixed point. Third one is stop it. And whatever you gave here, this is your options. If the customer selects this, the option is 1. If the customer selects this, the option is 2. Customer selects this, the option is 3. So that will be stored in your option. So you can take here, this as 10, 20, 30, and here you should write if option is equal to 20, 10, 20, 30. So by default, these are stored. You can hover the mouse here. You can see here, add menu entry, the label, the English name, comma, the value. So the value will be stored in this option. So once you're done with that, attach the menu to what button? Right button. Right button. You can write here as a left button or middle button or whatever, and run for it. Now this is, I am not done yet. Please bear with me. I am not done yet. I will now teach you, as we always do, keep the breakpoint and then run it. Now to do that, let me not take 1 degree. Let me take this. Let us say 5 degree. 5. Please look here. This is interesting. Any doubts? We have OS class at 12. 5 minutes, please. I'll call Chaitanya madam. Oh, I'll call Kirti madam. Yeah, I have informed. Last minutes, please look here. 5 degrees is what I'll rotate. Now please look here. Yeah, let me keep the breakpoint here. Oh, sorry, let me keep the breakpoint here. Swap buffers and rotate it. Sorry, debug it. Keep all your watch windows 100, 100. Okay. Now you should say run to cursor. Run to cursor. Run to cursor is apparently F4. Yeah, I'll now press F4. Now I'll press F4. It doesn't make any difference because the entire operation depends on my menu. So right click is disabled now because the control is staying there itself. So what I'll do is I'll make sure this is 2 now. Let us say this is 1. And now I'll run here. Debug it. I run. Take as 100, 100. Fine. Okay. Now comes the magic. F4 I'll press. I got it, and you can see I'm pressing F4, F4, F4. Doesn't make any difference because I have to select as option number 1. In fact, I have done it. Rotate. Okay, I have done rotation angle. Not supposed to do this. I'm supposed to do this. Debug it. 100, 100. Now it is interesting. So press F4. So 1 F4, 1 F4, 1 F4. You can see this difference. As long as 1 F4 will give me 5 degrees change. So you keep pressing F4 because your rotation, where to rotate happens to be to the 1. So every time we do this, repeat this. So your watches also gets changed, and this is a nice way to simulate for every degree. So I hope you enjoyed the session. I'll stop the recording, but